All right, last section in our class here. We're going to talk about how we multiply polynomials. Now, we've added them, we've subtracted them, we've done all the exponent work. Right now, we're going to talk about how to multiply them. Fortunately for us, you've seen part of this before. In fact, we've seen this idea called what's that called? Distribution. Do you remember distribution?
Yes.
Guess what? If you know how to distribute, you know how to multiply polynomials. We'll take a look at the distribution we've already had. I'll extend that concept to something new that we haven't had, and then that will be it for today. So, here's the idea of distribution. It was if you have some quantity, something outside of a parentheses, and you have a polynomial inside that parentheses. Notice that we have a polynomial here. How many terms are here, folks? 2. We can actually, bless you. Need a tissue?
Yeah, you have any?
No, I don't. Oh, I do. It's clean, I swear. Why is it gross? I didn't. Anyway, continue. We learned how to distribute a long time ago. Basically, when you have a term outside multiplied by a polynomial inside of those parentheses, we can get rid of those parentheses by the process called distribution, which means that we take our A, we multiply it by our B, and we get A times B, and we do we also do the A times the C?
Yes. Yeah.
And we do that with the signs taking care of themselves. Hopefully you remember that. The positive times a positive gives us a positive, so we would put a plus A times C. We do the A times B, we do the A times C. That's our idea for distribution. Do you remember that? We've been doing it for a while now. Let's do a couple simple examples and we'll build up to some things that we haven't seen quite so far. So, something we have seen before. We've got 3 times x minus 4. Can you tell me what two things am I going to multiply together first?
3x.
So 3 times x, and I'll give it 3x. Then I'm going to take that 3. Remember what I've had you do is I've had you circle that number in front of our parentheses and distribute it. Because I need you to know that that sign goes with it. You remember talking about that, how the sign goes with it? So this is positive 3 times positive x. That's why we get a positive 3x. This is positive 3 times, this one we actually consider it to be a negative 4. We consider it negative 4 because you could write it as plus and negative. That's the only reason why we do that. But the signs will take care of themselves. So can you tell me, what is positive 3 times negative 4?
Negative.
So what am I going to write?
Minus 12.
I'm going to write minus 12. That negative idea stands for minus. Again, because you could write it as plus negative and translate that back to a minus. So 3x minus 12. Raise your hand if you feel okay with this so far. All right. Now here's what we haven't covered yet. And you're going to be able to see that this is going to combine a couple ideas for you. Actually, several ideas for you. What if instead of having a 3 out there, I had something like a 5x? Instead of having just like an x minus 4 inside my parentheses, I had something like a 4x squared plus 7. Now, can you still see that distribution would work here? Do we still have the same idea? How many terms are inside your parentheses?
2.
Yeah, what are they?
4.
What's outside?
5x.
So just like we multiplied the 3 times the x and the 3 times the negative 4, we're going to multiply times each of those terms. Now I'm going to write it out because I want you to see where this is coming from. Check this out. If I've got my 5x times my 4x squared, I did my 3 times x. That's how I got 3x. So here, look what's going to happen. See how this is going to combine a couple ideas. This is 5x times 4x squared. Are you okay with where the 5x times 4x squared is coming from? Give me a head nod if you are. That's just our basic distribution idea. Now, how about this? Am I going to have a plus or a minus next?
Plus.
Good, because I have a positive times a positive. Are you with me on this?
Yes.
So plus 5x times 7, or 5x times or 7. You can't forget a term. You got to multiply the outside one times each of the inside one, no matter how many there are. Hey, now check this out. This is the cool part. Have you done problems like that before? Have you done problems like that before? Sure. Now this is going to combine our last section. This is 10.2 stuff. So here, this is 10.3. This is 10.2. How much are you going to get from 5x times 4x squared?
20x
20x.
to the third power?
To the third. Great, because you're multiplying. Remember that? Multiplying x times x squared, you're going to get x cubed out of that. This is why I was so hard on you guys last section saying, when can you do certain things? When you add them together, do you add exponents? No. When you multiply them together, do you add exponents? Yes. That's why I made sure you understood that going into your homework, because now we're putting it all together. Okay, plus sign's still going to be there. How about 5x times 7? I'm just going to get
35x.
35x to the first power. We don't have to write the 1. Last question. Can you combine now, ladies and gentlemen? Look at the board. Can you combine these?
No.
Can you get something like 55x to the 4th?
No.
That's something you got to know. What do you think?
Do you like that?
Are they like terms?
No.
No.
Now, you can multiply terms if they're not like terms. That's fine. But you can't add them. You cannot add them. So can you do anything past this?
No.
You're done. You're done. That's it. Can you multiply things that don't look the same? Yes. Can you add them? No. No. So that's where the difference comes in. You sure you're okay?
Yes.
I'd like you to try one on your own here real quick. Do this on your own. Make sure that we're following these steps. Show me all the work for right now. Trust me, show me the work. Don't do this in your head yet because you're just learning it, right? Show me those steps. That way I can see where you're going wrong on your homework and help you next time. There you go. So we're just on this one. We'll do that one together in just a second, okay? So hang off on that one. Hold off on that. Just doing this. Are you guys done on this one?
Yes.
Let's see what we got. First thing I want to see on your paper, I want to see is circling that term outside those parentheses. I want you to see those arrows distributing it. So we know 2 terms are going to get multiplied by the 4y. So the first term that we're going to have after we distribute is 4y times 8y squared. For right now, I want you to write that out. Now, in the future, when you get to Math A and Math C, look up here at the board. In the future, when you get to those classes, are you going to show this step? Are you going to show that step? No, probably not. You're going to go directly from here to here. Do you think you can do that when you get there? Yeah, probably. But for right now, I want to see the work. Because we're just learning this, I need you to show that, all right? So we've got 4y times 8y squared. Then we're going to have a positive times a positive. That gives us plus 4y times 5y. Raise your hand if you made it that far. Good, then you have down the idea of distribution. That's great, that means you know it. Now we got to apply the 10.2 step that we just learned. 4y times 8y squared, y'all tell me how much is that?
There's 2y's here.
To the third, great. Did you get to the third power? Not another squared, right? Because we know when we multiply those common bases, we actually add the exponents, and there's a little 1 right there. So we said the y to the first plus, times the y to the second means 1 plus 2, that's our third power. Then we have a plus here, and we're getting how much?
20y.
Oh, good. Yeah, you found it out. If we do y times y, we better be getting y squared out of that, right? Each of them have a power 1. If you add those, you're going to get y to the second power. Can you keep going?
No.
And you're done right there. Little head nod if you got that far. Yes, yes, yes. Yeah. Good, all right. Now wait a second. Does it work if I have more than just 2 terms?
Why not?
Well, let's try it. Means not just the first one, not just the second one, all the way to the third. So when we write this out, we're going to have 12y. Oops, I broke my own advice. We're going to have 3y times 4y squared. That's our first times our first. Then we've got a 3y times a 5y. That's positive, so we put a plus 3y times 5y. Now next, should I have a plus still or a minus?
Minus.
Good, and the reason why is because I have a positive 3y times what we consider to be a negative 9. I write minus, look how this works please, watch on the board very carefully. Do it this way. You're going to do your signs first because I told you the signs take care of themselves. So when you write this, watch exactly how I write this. I'm going to have a positive 3y times a negative 9. That's where I'm getting that minus from. Are you okay with that? Because we write negatives as minuses because you could write the plus negative and then change it to a minus. Then look what I do. I write my 3y times not negative 9 anymore, but positive 9. Do you see why?
It doesn't matter.
You've already taken care of that sign. Are you with me on that? You've already done it. You've already done the positive times the negative. You've already done that. You don't need to do it again. If you do it again, you're going to change that sign back. That would be the wrong thing to do. So you got your 3y times 4y squared, great. You got a positive, so we're going to run a plus. 3y times 5y, we got it. Then we go 3y times negative 9. That's where the minus is coming from, that negative right there. But we don't have to have that again. We've already taken care of the sign. How many people understand why we don't have another negative sign there? That's a big question. I need your hands raised if you do get it, and don't raise if you don't get it. Still not so much? Yes, no? Yes? Okay. Now we need to do the work piece by piece. How much is 3y times 4y squared? Good. Then we have a plus sign. We leave it as a plus sign. How much? Lastly?
Minus 27.
That's it. Can you combine any of those?
No.
They're all different. They're not like terms. Okay, I want you to try one of your own. Then I'm going to change the problem just a little bit, and we'll talk about it after that. So here's your example. Go ahead and work that one out. Did you make it? Make it. All we gotta do is distribute. You gotta make sure the term outside gets multiplied by every single term inside. Don't neglect the signs. Make them work for you. We got 3x times a positive 8x squared. I'm gonna write that out. 3x times 8x squared. I've just done the first set of terms. Next I have a 3x times, I consider those terms with a sign in front of them. That's why when we talk about this, if I said, oh, how many terms do I have? You'd all tell me 3, right? I'd say, what's the first term? You'd say 8x squared. I'd say, what's the second term? And you'd say negative x, wouldn't you? That's because the sign goes with that term, because you could write it as plus and negative. That's how we let those signs work for us. So we say, okay, what's 3x times negative x? 3x times negative x. Is it positive or negative?
Negative.
So I'm going to write a minus. That's where that sign goes. Takes care of itself, and then I'm going to write 3x times x. Not negative x, because I just used that over here. I don't need it twice. I've already taken care of it. Do you see why we have a minus here and no negative there? Nod your head if you do.
Yeah.
I didn't see a whole lot of head nods. It's yes, do yes. Because these are big things we're talking about. If it's no, go no. That's okay. Yes, no. Okay. And lastly, are we going to have a plus or minus at the end?
Plus.
Good. We have a positive times a positive. I'm going to write 3x times 11. So far, so good? Keep on working on it. We'll get 24 x to the third, 3x squared, 33x, and a show of hands on how many people made it that far. Good for you. That's fantastic. It's really good. Now, here's the one thing I'm going to change. I want you to go back and either rewrite this problem, which is what you're going to do. I'm just going to erase this. I want you to see the difference here. That's what we got on my original problem. I want you to see what happens, because this is important for you. This is what's going to be on your test. What would happen if I put a negative there? Would it change this stuff?
Yeah.
Would it change the first term, or the second term, or the third term, or two of them, or one of them? What's it going to change?
All of them.
Change every single one. Let's look at what happens here. Watch exactly what we do. We'd still circle that number with the sign. If I multiply it, check it out now. I've got a negative times a positive. I'd write negative 3x times 8x squared. Are you okay on that one? But watch what happens next. This is the important ones are the next ones. I've got a negative times a negative. Watch carefully. I've got a negative times a negative. What's that make?
Positive.
So I'm going to write a what? A plus. Pay close attention. If I have a plus, though, I'm going to have 3x times x. Well, now wait a second, Mr. Leonard, is what you might be asking. Why don't these have negatives anymore? Explain that to me. Why don't they have negatives?
Negative and a negative is positive.
So we already dealt with it?
Yes.
We already dealt with it.
Yeah.
So we're going to deal with those signs, let them work for us, let them take care of themselves, and then write the terms themselves being multiplied. Are you guys all right with that?
Yeah.
Otherwise, you have signs everywhere. You get negatives and positives and pluses and minuses. It's really confusing. If you let those signs work for you, treat them as term times term, it will become a little bit easier. Next up, I have negative 3x times positive 11. What's a negative times a positive?
Negative.
So I'm going to write that minus there. And then I'm going to have 3x times 11. I've already let those signs work for me. I've figured out all three of them. Notice only 3 signs now. Right? I don't have them everywhere. I just have those 3. I've already done the sign work. Now I just have to manipulate those. So I'd have negative 24x to the third plus 3x squared minus 33x. Essentially, all it's done is change every sign. Show of hands, how many people feel okay with what we talked about so far? Can you extend the concept even further? Could I have 1 term times 4 terms? Or 5 or 6? Sure. Now, the question you might wonder is, can you ever have more than 1 term times more than 1 term? Because we haven't talked about that yet. All we've done so far is 1 term times several terms. 2, 3, you can do 4, whatever. But we also have to master how to do this type of distribution. It's still called distribution. It's still multiplying polynomials, but check it out. What if instead of just 1 term, I had something like that? Is that just 1 term times 1 term? How many terms are here?
2.
How many terms are here?
2.
So you have a different story. You have 2 terms times 2 terms. We need to discover how you do something like that. Now, it's still called distribution. So when you say distribution, you could mean either this over here, distributed, or what I'm about to show you over here, what happens. Now, the idea was, for every term inside the parentheses, I multiplied it by the term outside. What this means is we got to do the same thing, only now instead of just 1 term, I've got 2 terms. So the idea is multiply every term in the first polynomial times every term in the second polynomial. That means this. What's my first term here?
Y plus 3.
No, the term, the first term. The
Y.
first term is y. What's the first term here?
Y.
I'd have to multiply y times y. Are you with me on that?
Okay.
I'd also have to multiply this first term times this second term, y times 5. I'd also have to multiply this 3 times, that's the second term, times this first term, y. And the 3 times this 5. I've got to hit every combination of terms times terms. That's what we got to do. So our idea is you're going to multiply every term in the first polynomial times every term in the second polynomial.
And the answer for that is what?
Now there is kind of a nice way to remember this. You might have heard this before. If you haven't taken this class before, you've heard it before, you've taken this class before. A lot of teachers use this, it's an acronym, which is the first letter of each word that you use. It's called FOIL. Have you ever heard of FOIL before? Then you've seen distribution at some time in your life. The actual word for it is distribution. So when your teacher in Math A says, how do I get rid of the parentheses here? You're not going to say FOIL, because FOIL is the way you do it. Distribution is the method of doing it. Do you understand the difference there? Both these things are called distribution. FOIL is one method you have to distribute 2 terms times 2 terms. Here's what FOIL stands for. FOIL stands for first, outside, inside, last. It's the way you can order these terms around. So first, outside, inside, last. First, outside, inside, last. Here's what we mean by first, outside, inside, last. Look up here at the board with me. I'll show you with my fingers what we're doing here. The first terms are y and y. Does that make sense? You multiply those first. The outside terms are these ones. Do you see the outside terms? I'm talking about, like, here's the middle, right? Those are my outside ones. These would be my inside terms, and these would be my last terms. This is just a way so you get every term times every term. You're also going to show me arrows on what you're going to be doing here. So here's how you'd show that. Your first terms are written like this. Watch on the board. You're going to do your first times your first. That takes care of my first terms, and I'm going to write that out, y times y. Y times y. Next up, I would do my outside. Looks like that. Y times 5. Now, ladies and gentlemen, let those signs work for you. Positive y times positive 5 gives you what? Positive or negative?
Positive.
So I'm going to write a plus. Just like we did over there, we let them work for us, we do the same thing here. Plus y times 5. You see where it's coming from? Am I done?
No.
No, I've only done half the work. I've only done this one times these 2. Now I've got to switch to which one? So y times y times 5, I got that. Now 3 times y, these are the inside ones. So first, outside, now we're on the inside. Is it going to be a plus or a minus, do you think?
Plus.
Good. Positive times a positive means a plus. 3 times y. And lastly, I've got the 3 times the 5. Am I going to put a plus or minus?
Plus.
Look at the board. Have we done every combination of terms?
Yes.
Get the y times y times 5. 3 times y, 3 times... That's everything. That's all 4 of them. Can we do each of these pieces?
Yes.
What's y times y, folks?
Y squared.
Oh, I like it. Y squared. Plus how much?
5y.
We don't write y5, do we?
No.
y5. Plus how much?
3y.
Plus?
15.
Am I done?
No.
Oh, hey, here's something neat. not only do we do distribution here, I just said neat, it's an old word, it's neat. We also did our 10.2 stuff by using exponents, but now we're going to do our 10.1 stuff. You can combine like terms here, can't you?
Yeah.
We got some y's here. So we've got a 3y and a 5y. I circle those with those signs, just like we've been practicing the whole semester.
8y.
Is it 8y or 8? This is where you got to be good at it. Is it 8y or 8y squared?
8y.
I have both answers going on out there. Let's have a battle royale. Figure this thing out.
8y.
Let me show you something in your brains that's happening right now. When you did y, listen. When you did y times y, you got y squared, right?
Right.
How can you do y plus y and still get y squared? Those things have to be different in your head.
Addition.
Multiplication and addition are not the same thing, are they?
No.
So if you're multiplying and you're getting y squared, when you're adding, you can't be getting the same thing. That's going to give you 5y. You're combining like terms. You've got 5y's here. You've got 8y's here. Oops, no, you don't. You have 3y's there. You have 5y's here and 3y's here. Altogether, you have 8y's. Not 8y squared. That doesn't happen unless you're multiplying. Do you see the difference? That's as far as you can go. Let's try one on your own real quick. Also, I need to point out to you that notice that this looks similar to addition subtraction, only instead of between the parentheses, I don't have a plus or minus. I've got a multiplication. So that means where you distribute. So if I give you this problem, look up here on the board here real quick. If I give you this, which looks just like something we've done before, are you going to do the same thing here and here?
No.
No, this one, would you have to distribute?
No.
No, it's add. It's just addition. You drop your parentheses and combine like terms. Here, yes, you distribute. So do they look real similar? Yeah. You gotta be kind of careful on that. Are you seeing what I'm talking about here, people? Okay. This one will give you 2x plus 5. That's what that would be. This one, when we distribute, hopefully you did this, we're going to write out x times x. We're going to write out plus, because I have a positive times a positive, x times 3. I'm going to write out plus because I have a positive times a positive, 2 times x. And lastly, positive times positive, 2 times 3. Raise your hand if you made it that far, please. Good deal. Now we do the work piece by piece. This should give us x squared. This should give us 3x. This should give us 2x. And this should give us 6. When I combine my like terms in the middle, which you'll typically have like terms on these problems, you have a 3x and a 2x. This is x squared plus 5x plus 6. Did you get x squared plus 5x plus 6?
Yes.
Awesome. Let's extend the concept a little bit. What if instead of just y times y, I have something like 4y and 5y? Can we still do it?
Yes.
Does it still look like distribution to you? Okay. Good. I still have the multiplication, right? It means I'm still going to multiply, and FOIL is still going to work because I have 2 terms times 2 terms. Why don't you tell me what's the first couple terms I'm going to multiply?
4y times 5y.
So I'm going to write that out. 4y times 5y. Okay, watch carefully, please. Watch carefully. What's the next couple terms I'm going to multiply? 4y and what was it? 3 or negative 3?
Negative 3.
Okay, so listen. Let those signs do the work for you. Here's what I'm talking about. If you got 4y times negative 3, a positive times a negative gives you a...
Negative.
So I'm going to write a what?
Minus.
The next thing I'm going to write is just those 2 terms being multiplied. So I'm going to have the 4y times the 3. Why not negative 3?
Because you already took care of it.
I already used that sign. I already made it minus. That's where that sign is going. Are you guys working on your own? Are you guys all right with this so far?
Yeah.
Yep.
Are you sure? On y, you have a minus there, but not a negative there. Okay. Well, we've done the first two. Now let's keep going. I've got 9 times 5y. Am I going to have a plus or a minus there?
Plus.
Write it out. And lastly, I have a 9 times a negative 3. Plus or minus, folks?
Minus.
Minus. And I'm going to have 9 times 3. I'm just going to write that 9 times 3. The numbers are being multiplied. I already used those signs to figure out that that's going to be a minus sign. That's how we use that to our advantage there. Raise your hand if you feel okay with getting that far in this problem. Now let's continue. How much is 4y times 5y?
20y squared.
Multiplying there, we can take a y times a y, get y squared. Minus how much?
Minus 12y.
Good, 12y plus,
45y.
oh my, 45y. And then minus 27. Are there any like terms to combine?
Yeah.
Sure.
45y.
Am I going to get a y squared when I combine those?
No.
So I get 20y squared plus, this is a problem, these problems you can expect in your test, something like this. Yeah,
Is there ever going to be like a big problem in this type of string?
yes. I'll show you some. Just hang on a minute. Before that though, I want you to try one on your own. Okay, work on that one. Let's take a few more seconds, try to wrap that up. Remember, we're taking every term in the first polynomial times every term in the second polynomial. That's what we mean when we have these parentheses next to each other. It means multiplication. The only way we can do that is with distribution. So show in your work, let the signs take care of themselves, then multiply each term times each term.
You do like, you know how the negative is 9 to 7x? But when you're multiplying 7x by the 4, do you make it positive, like plus or negative?
Every time you see a plus and a minus, it goes with the sign that's behind, it goes with the term that's behind
The
it.
number, right?
This number, yeah. So this is a positive 7x times a positive 5x, you should have a positive.
Yeah.
Positive 7x times positive 4, you should have a plus. Negative 1 times positive 5, you should have a minus. Negative 1 times positive 4, you should have a minus. So this should go positive plus minus minus. So let's look at that. I hope on your paper you get 7x times 5x. Did you get that? Also, you should have a plus 7x times 4. You see, you let those positives make it a plus for you. Then you should have a minus, because you have a negative times a positive, 1 times 5x, and also a negative times a positive, 1 times 4. Raise your hand if you made it that far, exactly like that. Good deal. All right, work it out step by step. We got 35x squared. We've got a 28x. We've got a, 1 times 5x, that's going to give you, and lastly, how much? When we combine like terms, which is usual for this type of distribution, we're going to have some like terms here. 35x squared plus 23x and then minus 4. Yes, no?
Yes.
Kind of works out kind of nice for us, right?
Yeah.
Now, you know, a lot of times, I showed this to you actually already, a lot of times people will make a mistake on this problem. They'll think it's something it's not. I know I've showed you a lot of new stuff in the last few days, a lot of stuff with exponents and everything, but I gotta be honest, I still have people who just took the test on chapter 12 of Math C, which is 2 classes beyond you at this point exactly, and they're still making mistakes on this. So I'm gonna remedy this right now so that if you ever take me in Math C, you won't make this mistake. A lot of people will look at this problem and do this. you see how they're getting that? A lot of people give me that. Some of you are in this classroom because of mistakes like that. Okay, because you might have had this class before, but you kept doing things like this over and over again. We're going to fix that right now. I need you to understand what 3y plus 1 squared actually means. What's that squared actually mean? Ah. So let's look. I'm going to hold this on the board. We're going to see if it's right. So would you agree that 3y plus 1 squared actually means this times that? Let's work that out because we know how to do it now. Well, 3y times 3y plus 3y times 1 plus 1 times 3y plus 1 times 1. Can you follow me on where those things are coming from? I've just done a work, I've done it a little quickly, but can you see where that distribution is coming from? You sure, guys up here? Yes? No? Okay. Hey, what's 3y times 3y?
9y plus
So far it looks the same, doesn't it?
Yeah.
But this gives you what?
Plus 3.
And this gives you, and this gives you, look what happens. Look, you get the first thing right, and you get the last thing right, but doing it this way completely omits those middle terms. And that's a big problem. Because when I add these together, I get 9y squared plus, how much is it?
6y.
Not squared, 6y plus 1. Remember, you're adding, you're not doing anything with those exponents, 6y. So what's the difference between those two? Besides one's right and one's wrong. This one has the 6y and that one doesn't. This one for sure is right because we just worked it out, and this one's not. So can you just square this and square that?
No.
Can you?
No.
Really? Was that right? No. Can I just square this and square that? No, you have to actually distribute it. Try this for me one time. Be careful because I have a minus there. Okay, you're going to have to look at that as you're on the second part of your problem. Be careful.
The second one's right?
This one.
Yeah.
That's why I crossed that one out. This one's right.
Yeah. It's a little bit confusing though because
Guys, this is why I made you learn those exponent rules so well, or try to, because this looks a lot like an exponent rule you just had, doesn't it?
wouldn't we have solved that like that in a certain, like a different math problem or no?
This is the only way you can do that. That's it. So it looks very similar to some things we just had. You got to be very aware of what each one of those specific problems mean. We'll do that one in just a second. Okay, first thing, ladies and gentlemen, can you just square 6x and this minus 1?
Nope.
No. What do I have to do?
Make it a problem.
I got to write it out. Yeah, I got to understand that this actually means 6x minus 1
Times 6
times itself. That's all it means. That's what any square means. It means something times itself. X squared means x times x, right? So 6x minus 1 squared means exactly that, itself. When I multiply, you should have on your paper 6x times 6x. Yes?
Yes.
Okay, watch carefully. Watch on the board with these minuses. You've got 6x times negative 1. That should be minus 6x times 1. Do you see where the minus is coming from? Then you have negative 1 times 6x. That's a minus 1 times 6x. Yes, no? Lastly, it's a biggie. Negative 1 times negative, what's a negative 1 times a negative 1?
plus.
A plus 1 times 1. Okay, show of hands, how many people have that down? Oh, if you got that, you got this stuff down. Okay, you understand the concept. If you got it that far, you're golden on distribution. You understand exactly what to do. So congratulations, you got it. We work it out step by step. You get 36x squared minus 6x and plus 1 or plus 2?
1.
One.
Plus 1. You're multiplying that. So 36x squared minus 12x plus 1, and you are done with that problem. You can't do anything more. Do you feel okay on what we've talked about so far?
Yeah.
All right, now, can you extend the concept a little bit further?
Sure.
What if we don't just have 2 terms times 2 terms? What if we have 2 terms times 3 terms? Can we still do it?
Yep.
Yes.
The concept of distribution still applies. It says take however many terms you have in the first one times however many terms you have in the second one and just keep distributing. So FOIL isn't exactly going to work because FOIL means first, outside, inside, last. We've got several insides, right? So it's kind of like FOIL. We got like FOIL going on. So first and then outsides, insides, and all that stuff going on. Basically the idea is take everything here, multiply by everything here. That's the idea. So can you tell me, can extend this concept, what's the first thing I'm going to multiply? Let's go kind of quickly through this.
4x times x squared.
So 4x times x squared. Very good. Then what?
4x times
Negative
negative 6.
So plus or minus?
Minus.
Minus
Keep going.
4x
Uh-huh.
plus times.
Good. Where'd the negative go? Oh, it's right there. I've already used it. Then what?
Plus
4x times 3.
Good, good. Plus, like it, 4x times 3. This just did this first term times all 3 of those ones. Do you see where that came from? I'm done with the first term, now I move to the second term. Positive 2 times positive x is positive 2 times x squared. Then am I going to have a plus or minus, folks?
minus
Good, good. Because I have a positive times a negative, that means a
2x times
2 times 6x. You still sure you're okay? Let's see if we got it. We got 1, 2, 3. That's these 3. Then we got 2 times x squared. Yep. We got 2 times negative 6x. Use the signs for you. That's a minus 2 times 6x. You still sure you're okay with it? And then lastly, I've got what?
plus 2 times 3.
So if we do the math, we've got 4x to the third. We've got minus 24x squared. We've got plus 12x plus 2x squared minus 12x plus 6. My goodness, that's a lot of stuff. Can you make it that far? Are you seeing why we covered like terms before we did these problems? Yeah, because now we got a lot of like terms combined. Do I have any like terms of 4x cubed, folks?
No.
So I'm going to start there. Remember, I like to start with the bigger exponents and work my way down. It's got to be in order. Next, I check for any other x squareds. Do I have any other x squareds? How much does that make? Lastly, I've got a 12x and, oh, how much is that?
24x.
Careful.
Just cancel.
Okay, so there's nothing. And then lastly, I got a plus 6. That's as far as you can make it. That's as far as we can go. Do you feel okay on doing these types of examples with this distribution? Okay, that's it. All I would do from now on is give you a couple examples to study from, but that you have on your test review.